How can I graph and apply transformations to absolute value functions? There's two big things here. We're talking about just absolute value functions, what they look like and how to graph them, and then also the transformations of them. So the parent function here is going to be y equals the absolute value of x, or f of x equals the absolute value of x. In this case, if you were to just start putting in points for x, substituting in values of x, and then coming up with your y's, if x is 0, y is 0. If x is negative 1, y is 1. If x is negative 2, y is 2. If x is 1, y is 1. So you can see that you're going to have two places in which y is 1, y is 2, so on and so forth. What this is going to create is going to create a vertex and a V-shape graph. In this case, in the parent function, the vertex will be the origin, or 0, 0. When x is 0, y is 0. Then to the left, it will go up, and to the right, it will go up. Like this. So on here, y equals the absolute value of x. This is what the graph would look like. At 1, 1, and at negative 1, 1, you have there. Now, there's some important features of these functions we want to talk about. Your domain. The domain is going to be all values of x, so from negative infinity to positive infinity. And remember, we use parentheses because you can't actually include infinity within your domain or your interval. Range is going to be from 0 because it doesn't go below 0 to infinity. So our range here is from 0 to infinity, and 0 is included because it is a y value, but nothing below 0. The concavity of this is up, and that's all going to have to do with what we're going to call the a value in front of the absolute value symbol. You can also have concavity of down, where it goes faces downward. So what are some other features? We have increasing and decreasing. All absolute value functions have a part where they're increasing and part where they're decreasing because of the nature of them. This function, the parent function, increases from 0 to infinity and decreases from negative infinity to 0 inclusive. So that's where we have a bracket versus a parenthesis there. There are two rates of change, or two slopes within this. There's kind of this left side slope, which in this case is a slope of negative 1, and a right side slope, which is a slope of 1, where the increasing slope, which will be positive, and the decreasing slope, which is negative. These slopes will generally have the same absolute values. So it'll be 1 and then the opposite of 1. They'll generally be opposite, they will be opposite slopes. All right. So here's the general form of an absolute value function, which so far the h and k values have been 0, because ultimately your vertex is h comma k. So if you do x minus 0, that's just x, plus 0 is just, you kind of leave that off. So y equals the absolute value of x. H is a horizontal shift. So if you do have an h value, you're going to shift to the right h. Now, if it says x plus a number, that means that h is actually negative, so we shift to the left, that number. K is a vertical shift, so you go up or down depending on what k is. Down would be if k was negative and would likely look like subtraction, and that's just simply you kind of shift your vertex in that direction and then draw your lines based on the slope. And slope is actually a. A is going to represent the slope of the right side of the from the vertex. So if you go to the vertex, the slope to the right will be the a value. The slope to the left will be the opposite of the a value. So if a was 1, the slope to the right would be increasing of 1, the slope to the left would be negative 1. And that represents also a stretch or compress. Stretch is going to be when a is less than 1, and compress when a is less between, when a has an absolute value less than 1, and a compress would be when a has an absolute value greater than 1. And when a's absolute value is 1, then you're just looking at the parent function. Let's take a look at some examples of some shifts. So in our parent function, y equals the absolute value of x, the vertex is h comma k, in which h and k are both 0. So our vertex is right there at the origin. Here, the vertex is at 2, 1. So h is 2, k is 1. So we would write that as y equals the absolute value of x minus 2 plus 1. So we have the x minus 2 in the absolute value symbols. We add 1. 2, 1 is our vertex. And that just shifts this function over 2, up 1. And now we're going to look at what the a value does. So we're kind of ignoring the h and k here, and we're going to have a vertex at the origin. And in this case, we're saying a, that's the slope that's stretching and compressing. So generally speaking, this red one is what will happen if a is greater than 0. If a is less than 0, you're going to have a negative concavity and it's going to face downwards. So that's what the positive and negative values do. Positive has an upwards concavity, negative has downwards concavity. Now, for example, I want to show you that when a is greater than 1, you're compressing the graph. So what that does is you see this purple graph up here. If x is 1, the absolute value of 1 is 1, but then times 2, because a is 2, puts you up to 2. So it's 1 comma 2. And your graph kind of gets narrower, or you have a steeper slope on both sides. Both the decreasing and the increasing are kind of steeper. If a is 1/2, then you put in a value of 1, or say let's do 2. If x is 2, well, 2 times half is 1. So you just go over 2 up 1, and you have a less steep slope. So it kind of widens. It stretches the graph, so to speak. And that is just very quickly how I can graph and apply transformations to absolute value functions.